In this video, we are talking about the topics of chapter 12, which is titled Alcohols, Thiols, Ethers, Aldehydes, and Ketones. In this chapter, we are going to focus on the nomenclature and reactivity of some of these functional groups expressed in the title. We are first going to be discussing alcohols. And you may be wondering, what is an alcohol? To be reminded, based on the concepts that we learn in chapter 11, an alcohol is going to be a molecule in which the rest of the molecule, or the R group, has a chain of carbon atoms. That chain of carbon atoms can be carbons and hydrogens, as we can see in this example for an alcohol called methanol, or that R group can be a benzene ring, as we can see in the example of phenol, which is also an alcohol. When it comes to alcohol, it's important to notice that organisms in nature can actually produce alcohols. So if you have ever wondered, how is it that products like beer or wine obtain their alcohol, which more specifically, the alcohol content in these products comes from ethanol? That alcohol molecule is actually produced from the biochemical reactions that take glucose, which that is called a sugar, and we will spend some time in chapter 13 talking about sugars, and through biochemical reactions, it turns into other molecules, including the one that is called pyruvate. Again, we're going to learn about this compound in the next chapter. And ultimately, yeast will convert sugars to alcohol molecules, specifically ethanol. The next functional group that we have is an ether. In an ether, the oxygen atom on either side must contain carbon chains. Here we have an example of an ether. We have an oxygen atom connected to a methyl group on either side. You may be wondering, why are ethers important? Well, ethers were used as the first real anesthetic back in the day. We no longer use ether as an anesthetic, but it is important to note that in the beginning, when surgeries were performed, ether was one of the substances that was used in order to be specifically an anesthetic. Next, we have a thiol. And thiols are characterized by having a carbon chain connected to an SH group. Here we have an example of a thiol, where we have a carbon chain connected to an SH group. Later in the semester, we are going to learn about the biomolecules called proteins. And in proteins, we actually see that thiol group as an important functional group in order to give structures to those biomolecules. Now we're going to focus on nomenclature. And the first thing we're going to learn how to name is going to be alcohols. On the left side of the slide, we have the steps on how to name alcohols. First, we have to name the longest carbon chain attached to the OH group. So the carbon that contains the OH group must be included in the parent chain. You can write the alkane name, but because we have an alcohol, the E in the alkane name will be replaced by OL. Next, we have to number the chain starting from the end that is nearest to the carbon that is attached to the OH group. Next, we have to give the location and the name for each of the substituents relative to the numbering that we already gave to the carbon that has the OH group. When it comes to naming alcohols, please do not forget all the different ways that we know how to name substituents that we learned in chapter 11. Let's do the examples that we have on the right side of the slide. Starting with this structure, take a moment and identify what is the longest carbon chain, meaning the one that it's going to give us the name of the main chain, or in other words, the parent chain. As you can observe, in this molecule specifically, my parent chain has 1, 2, 3, 4, 5, 6 carbons in length. In this molecule specifically, you could have also selected 1, 2, 3, 4, 5, 6 as your longest carbon chain. Either direction will be correct, and it will result in naming the same molecule. Since we have 6 carbons in a parent chain, then that means that if we write the alkane name, we will write hexane. But because this is an alcohol, our parent chain is going to be called hexanol. We must write where is our OH group in that parent. And we're going to do that by writing the number of the carbon where the OH group is sitting. As you can see in this molecule, at carbon 2 is where we have our OH. In this molecule, if I highlight the parent chain, we only have one substituent on carbon 5, and the location and the name of the substituent is going to be placed as a prefix of the parent chain. So on carbon 5, I have a methyl group. So the correct name for this molecule is 5-methyl-2-hexanol. Please remember that when we're numbering the parent chain in alcohols, we're going to start at the end that is closest to the carbon that has the OH group. That's why we had to number this one from right to left. Take a moment and name the following alcohol. The parent chain for this molecule is 1, 2, 3, 4 carbons in length. So if I write the parent chain, let me highlight it. Carbon number 1, 2, 3, 4. Since I have 4 carbon atoms, that's why this is butane. But because it's an alcohol, this is butanol. It happens to be that the OH group is specifically at carbon 2. And we have one substituent on carbon 4. And since it's Br, that substituent is called bromo. In terms of the punctuation, when it comes to this functional group, please do not forget to always put a hyphen between numbers and letters. Alcohol molecules can also be cyclic. And in the case of cyclic alcohols, this is the way that they're numbered. The carbon that is holding the OH group In a cyclic alcohol, we will always number it as a 1. Next, we are going to number the rest of the carbons in the cyclic system clockwise or counterclockwise, such that the substituent, if present within the ring, will have the lowest number. In this example, we must number the cyclic system counterclockwise. So this is position 2, this is position 3, this is position 4, this is position 5, to give that substituent the lowest number. When it comes to naming the parent chain, since this is a cyclic alcohol, we can write the name of the cyclic alkane. Since there's 5 carbons in the cyclic system, this actually came from cyclopentane. But because this is an alcohol, we're going to take the E ending and we're going to write OL. That means that the parent chain is called cyclopentanol. Since in a cyclic alcohol, carbon number 1 will always be the one carbon atom within the cyclic system that is holding the OH, is not necessarily that you put 1 cyclopentanol, because that carbon is always going to be in position 1. As a prefix of the parent chain, you must place the substituent. And in this molecule, on carbon number 2, we have a substituent that has 1 carbon, 2 carbons, 3 carbons. And since it is connected through the end of that carbon system, meaning that this is a CH3, this is a CH2, and this is also a CH2, that substituent is called a propyl group. So the correct name for this molecule is 2-propyl cyclopentanol. In the slides, we have different examples. I'm going to specifically do the last 2 in the second row for the examples. Make sure that when you have time, you go over the in-class worksheets and you continue to practice the nomenclature for alcohols. So let's first deal with the molecule that we have on the left. Take a moment and determine what is the number of carbons in the parent chain. Remember that we're going to start from the end that it is closest to a substituent. So when it comes to this, we have 1, 2, 3, 4, 5, 6, 7, 8 carbons. Let's now determine what is the name for our parent chain. Since our molecule has 8 carbons, the parent chain is known as octa-NOL. That is octanol. Since this is a straight chain alcohol, we must place what is the position of the OH in my parent chain. For this alcohol, at carbon number 2 is where my OH is sitting. If I highlight my parent chain, anything outside of that, that is a carbon chain or a halogen, I can determine as a substituent. Specifically in this molecule, on carbon number 5, I have a substituent that has 1 carbon atom, 2 carbon atoms, 3 carbon atoms. And since it is a 3 carbon atom system, and I'm holding that substituent by the middle one, that's the connectivity to the parent, That substituent is known as isopropyl. My isopropyl molecule is on position 5 in my parent chain. So the name of this compound is 5-isopropyl 2-octanol. On the right side, we have an example of a phenol. So whenever we have a phenol in the structure, and I'm going to highlight it, phenol is going to be that benzene ring connected to OH. The phenol structure becomes our parent chain, which means that that is the last word in the structure. Similar to cyclic alcohols, because in essence, this aromatic alcohol is cyclic, the carbon that is holding the OH is going to be carbon number 1. Next, we are going to number the ring clockwise or counterclockwise to give that substituent the lowest possible number. For this specific example, doesn't matter which way we number it, clockwise or counterclockwise. I choose to write it clockwise. This is position 2, position 3, position 4, position 5, position 6. If we would have gone counterclockwise, meaning that this was 2, 3, 4, 5, and 6, you can observe that the substituent will still be at carbon number 4. This substituent in particular, because it has 1 carbon atom, 2 carbon atoms, 3 carbon atoms, and it is connected via the last carbon atom that is known as a propyl group. And this propyl group is sitting on carbon number 4. Remember that numbers and words are always separated by a hyphen. Continue to practice naming alcohols. In addition, it is important that you guys know how to go from name to chemical formula. I am specifically going to do the bottom example in order to illustrate how to draw cyclic alcohols. Make sure that you practice the upper example for 2-methyl-3-pentanol. So in the bottom, we have 1-chloro-cyclobutanol. I'm going to start by drawing the skeletal structure. If my molecule is named cyclobutanol, that means that I have 4 carbons in a cyclic system. As we learned in the previous chapter, 4 carbons in a cyclic system looks like a square. Because this is cyclobutanol, somewhere in the molecule, I have to write the bond to OH. You can choose this position, this position, this position, or this position. Just write it somewhere. Once we have done that, the carbon that is holding the OH becomes carbon number 1. Next, because it says that we have a substituent also on carbon 1 that is called a chloro group, since I wrote that this is my carbon number 1 because I see the connectivity to the OH, then I'm going to proceed to write also a chlorine attached to that molecule to represent the 1-chloro-cyclobutanol. When it comes to this, then I can take my molecule and then include the carbons and hydrogens that are surrounding the system. In the condensed structure for 1-chlorocyclobutanol, there's a carbon right here. 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 This is how we include the hydrogens. This is a CH2. This is a CH2. This is a CH2. And lastly, because this carbon atom is connected to 1, 2, 3, 4 lines, no hydrogens must be added. As I mentioned, make sure that you practice how to name alcohols, how to name phenols, how to name cyclic alcohols, and how to also go from name to chemical formula.